Hey, hello everyone. Welcome back to the channel Code Management. So in today's video, we are going to cover 60 very important Java basic interview questions. So these questions are especially useful if you are preparing for Java developer interviews and particularly around the 2 to 5 years of experience range. But there is one important thing I want to mention that I don't want this video to be just a list of questions and one line answers. For every questions, we will understand like what it is, how it works internally, a small code example, and what kind of follow-up question an interviewer can ask you. So if you are preparing for Java, Spring Boot, microservices, or backend development interviews, I strongly recommend that you don't just memorize these answers. Understand the concepts behind them. So let's start. And always just remember the interview format should be like first definition, then workflow, then code example, practical use case for your uh, maybe it is personal project or the professional project, and then the key limitations, what are the advantages. Okay, so in that way, your answers should be not just definition. Okay, so first question is like, what is Java? So Java is a high level class-based object-oriented programming language. So one of the biggest advantages of Java is platform independence. So when we write Java code, we don't directly compile it into machine code for Windows or Linux. Instead, the Java compiler converts our source code into something called bytecode. So this bytecode is stored inside a dot class file, and then JVM basically takes that file, like takes that bytecode and executes it. So the basic flow is like Java source code to Java compiler, Java C compiler, then uh, bytecode. So it will be stored in a dot class extended file, and then JVM will take that and to the particular operating system. So for example, I have prepared one hello class, and there only main method is there. I'm just printing the hello Java. So you can compile using this command java c hello.java. So when we will do that, then basically this generates hello.class file. And then to execute it or to run this program, you need to do Java, then class name. Here our class name is hello, so Java hello. So in an interview, don't just say Java is object oriented. So better answer should be like Java is a high level class based object oriented programming language that compiles the source code into platform independent bytecode executed by the JVM. Okay. So just think the approach. So what I have discussed, like the definitions, flow, example, use case, right? So suppose you have gone to give the interview and you were just told about the definition, not in that way. And suppose another candidate went, and suppose he or she is giving that way. Suppose their answer approach is like that way, the definition, flow, code example. Then the interviewer will select whom, you or the another candidate. Just think in that way. Okay. So next question is, why is Java platform independent? So now the interviewer can immediately ask, like, if Java is platform independent, then how does the same code run on Windows or Linux or Mac OS? So the answer is bytecode and JVM. So suppose I write Java code on Windows. So the Java compiler creates the bytecode, what I've told. So that bytecode doesn't belong specifically to Windows. So now I can take that dot class file, which consists of that bytecode, and execute it on Linux using a Linux JVM, or like macOS with the help of macOS JVM. So remember this very important statement. Java bytecode is platform independent, but the JVM is platform dependent. So that's a very common interview question. Okay. Next is like, what is JVM? So JVM stands for Java Virtual Machine. The JVM is responsible for executing the Java bytecode. What I have shown you here, the JVM will take that bytecode dot class file, and for particular operating system it will execute. So in that way, basically JVM is responsible for executing the Java bytecode. But the JVM does not much more than simply execute code. Okay, so uh, so it it does many more things, not just like only executing the Java bytecode. Okay, so it handles the class loading, bytecode verification, then memory management, garbage collection, execution. Okay, there is execution engine which is called as the JIT. Okay, so these type of works also it does. So this is the dot class bytecode. Then through the class loader, it will take that, load the classes. There are three types of class loader as well. Maybe I will discuss later. Then bytecode verification happens. Then runtime data areas, then execution engine through the JIT, then native machine code. Okay. So at a high level, when the dot class file will come up, it goes to the class loader. Then bytecode is verified and runtime memory areas are created, right? And finally, the execution engine executes the bytecode. So the JVM can also use JIT compilation or just-in-time compilation. What I was telling, the execution engine, there is the JIT compilation. And what is the function of that? The function is to compile frequently executed bytecode, and it will be converted to the native machine code. So what JVM compiled, JIT will take that, and it basically, what it does, it will compile frequently executed that bytecode into native machine code. From that bytecode to native machine code conversion, JIT basically helped. So if the interviewer asks like what does JVM do? So you need to mention the class loading, verification, like bytecode verification, execution, memory management, garbage collections. Those things you need to tell. Not just like it will take the bytecode and send to the particular, like execute that bytecode. Not only that one. Okay. So class loading, bytecode verification, execution, memory management, then garbage collections. Okay. Next is difference between JDK, JRE, and JVM. So this is probably one of the most common Java interview questions. So let's make it very simple. Like JVM is responsible for executing bytecode mainly, but other than that, whatever other task you also can mention. Then JRE basically provides the environment required to run the Java applications. So it consists of like JVM plus other runtime libraries. Okay, and JDK, the JDK is used by developers. So it provides the runtime environment plus development tools such as the Java compiler. So always remember, JDK is JRE plus development tools and JRE is JVM plus runtime libraries. And JVM is, you can tell it as a bytecode execution engine. Okay, so one important modern concept is like starting with Java 9, Oracle no longer distributes a separate standalone JRE in the old way, but the conceptual distinction is still very useful for interviews. Okay, so like after Java 9, you will not able to see any separate JRE. Okay, you can directly download the JDK, and in that JDK already JRE is there. Okay, so next question is, what happens when you run a Java program? So let's understand this from beginning to end. Like we start with suppose some demo.java. Okay, so we run Java C, then demo.java. The compiler will generate the dot class bytecode like demo dot class. Then we execute Java demo. So the JVM basically starts, right? The class loader then loads the class. You can think in like this flow now. So the JVM will starts, then the class loader loads the class, the bytecode is verified, JVM prepares the runtime environment, then the main method is invoked, right? So after that, during the execution, frequently executed code can be optimized by the git compiler. So the interview flow will be like source, then compilation, then bytecode. After that, like class loading, then verification, execution, and then you can tell like GIT optimization, like through the GIT, actually, like whatever frequently executed code, it can be optimized by the GIT compiler. So you can tell the last step as the GIT optimization, right? Okay. So after that, we are starting the OOP concepts. Okay. So the next question is like, so here I have given the example as well, this flow, that dot java java c dot class bytecode, right? Then class loader, verifier, JVM execution engine, then main method. Okay. So the next question is like, why is Java not purely object oriented? So Java is object oriented, but technically it is not considered a purely object oriented language. But why? Because Java has primitive data types. Like for example, int x equals to 10, that is primitive. Integer y equals to 10, that is the wrapper object. Then list of integer of list. Then new array list. And here we are doing list dot add 10. So here what we have done, that is auto boxing. So int, boolean, char, all Java supports. So those are the primitives, not objects. So also Java provides the wrapper objects. Okay, like for int it is integer, for boolean it is boolean, for char character is there, for double, caps double is there, right? But primitives still exist. So therefore Java is not considered 100% pure object oriented language. Okay. So next question is, what are the four OOP principles? So there are mainly four major OOP principles. First one is encapsulation, then inheritance, polymorphism, and abstraction. So think about a real world banking application. So encapsulation protects account data. You can give the example like that. So in the banking application, it protects the account data. So that is the example of encapsulation. Then inheritance allows different account types to reuse common behavior. Polymorphism, you can give example like it allows different payment or account implementations. Then abstraction, it hides the implementation complexity. So these four concepts like form the foundation of the object oriented programming. Now what is the encapsulation? So encapsulation means bundling the data and the behavior together while controlling access to internal state. Now we have created the class bank account, and there we have a field like private and type is double balance. And then we have made the deposit method, and there is get balance. So you can see here the balance is private. Nobody can directly do like account dot balance equals to minus 1,000 like that. No one can do that as we have made it private. So instead they must go through deposit method. So these allows us to apply the validation. So encapsulation provides the data protection plus controlled access. plus validation. And also you can say it also helps for maintainability, like securely, how can we maintain that also it supports, right? So again, I'm telling, so encapsulation means we are wrapping up the data and behavior together while we are controlling the access to internal state. Like if you want to do anything on top of balance, then we need to go via deposit method only. Okay, from externally, we cannot just do like account dot balance uh, minus 1000 like that. We cannot do like that. So I hope the encapsulation is clear, right? So the next concept is inheritance. So inheritance basically allows one class to acquire the properties and behavior from the another class. So that's why we have made one class is animal, and it has the eat method, and we are printing eating, and then the class dog extends the animal, and there we have the method bark, and the printing we are printing as barking. So here dog is an animal, right? So this represents an is a relationship. So dog inherits the it method from the animal, and it also has its own method bark as well. Okay. So inheritance basically promotes the reuse. Like although in modern application design we should avoid creating like deep and unnecessary rigid inheritance hierarchies. Okay. So like in that type of dependency will not do. Okay, but yeah, that's the concept of inheritance actually. Now immediately the interviewer can ask you the next question, like does Java support multiple inheritance? So Java does not support any multiple inheritance through classes. So just imagine, like suppose both class A and class B have the same method, so which implementation should C inherit? So this creates ambiguity. So therefore Java does not allow like class C extends A comma B. If we will make the class A and class B, then it will be not supported by Java that class C extends A comma B. But Java allows class C implements A comma B if there are interfaces of A and B. So this gives the Java a way to support multiple contracts while avoiding traditional multiple class inheritance. Okay. Next is like what is polymorphism? So basically polymorphism means one interface or a parent reference, and which can represent multiple implementations. Suppose here animal reference is there, and then there is the dog object, cat object. So dog dot sound, cat dot sound. So here we have the reference type is animal, but the actual object is dog. Therefore, the dog implementation executes. So this is like runtime polymorphism. So here we have made the dog object from the animal, right? This animal equals to new dog. So the reference type is animal, but the actual object is dog. We are making the actual object of dog, right? Therefore, the dog implementation executes. So this is one runtime polymorphism. So this concept is extremely important in Spring Boot because dependency injection heavily relies on programming against interfaces. Okay. So here, when interviewer will ask me that what is polymorphism, I will not stick into that. That is the polymorphism and that is the example. I will also tell that where it will be used or where I am using that one. So this concept is extremely important in Spring Boot. In that way, I will say to interviewer. Then interviewer will be impressed. Why? Because he or she will know that the candidate already know about polymorphism and why we are learning this, where we will implement this, right? So so we can tell in that way that this concept is extremely important in Spring Boot. But why? Because dependency injection heavily relies on programming against interfaces, right? So now, what is method overloading? So method overloading means same method, same method name, but different parameter list. So there is like a class calculator is there, and we have the one add method, and there we are passing two integer type parameters. Okay, so int a int b, and we are returning a plus b, and another we have also another method add, and there we are passing three parameters int a, int b, int c. Okay, so the compiler determines like which method should be called. So therefore, overloading is called the compile time polymorphism, adds as like compiler will determine like which method should be called. Okay, so like changing only the return type is not enough. Okay, so what is the method overriding? So overriding happens when a child class provides a new implementation of a parent class method. So suppose this is class animal, here it is the method as sound, right? And here we are suppose printing animal, or suppose some logic is there, business logic is there. Now from class dog it extending the animal, and we are overriding the sound method, but now we are printing the bark method, like we are printing the bark, not the animal. Or suppose some different functionality also or feature you can also write. So when we do like animal a equals to new dog, and suppose a dot sound, so dog's implementation will be executed. We will get the result as bark here. So that is actually the method overriding or the runtime polymorphism. Next is overloading versus overriding. So remember this table mentally, like whenever that is overloading, that is same name, different parameters, and compiler will just schedule like what not schedule like compiler will actually decide like which method should be called. Okay, so that is the compile time. And when overriding, there the same signature, parent child relationship, and runtime. So if the interviewer asks for one example, then you can give like add, and inside that two int parameters we are passing, and after that one another add method, and we are passing suppose three integer parameters. So that is one kind of overloading example. And here when we are doing suppose this is class animal, there suppose some method is there, some implementation we have done, then one child class extending that parent class, and we will override the method which had the which had in the parent class, and then we will write some different implementation, and then we will call that like what I have told, like animal a equals to new dog, and then a dot sound. Okay, then we will get the uh, implementation from that child or this dog class. So that is one example of the method overriding. Okay, so that is in the runtime. Now what is abstraction? So basically abstraction means exposing the necessary behavior while hiding the implementation details. So we will only show the behavior, not all the things. The implementation details we will keep hide, right? So just think about ATM. So we press withdraw. We don't care how the bank validates the account, checks the balance, communicates with the core banking systems, and records the transactions, right? So we only interact with the abstraction. So in Java, abstraction can be implemented using interfaces and abstract classes. Okay. So now the next question will be abstract class versus interface. So this is another very common interview questions. So an abstract class can contain instance variables, constructors, abstract methods, concrete methods. Okay, so a class can extend only one class, but interfaces are primarily used to define the contracts. Like a class can implement multiple interfaces. So a simple interview rule is like use an interface when you want to define a contract or some capability, and you need to use the abstraction or abstract class when closely related classes need shared state or some implementation. Okay, so in the interface you will just define the contract or some capability, and in the like abstract class, there when there is closely related classes, then there you need like closely related classes need shared state or implementation. Okay, now next is like what is an interface. So an interface defines the contract, what I have told you. So here the interface payment service and class card payment implements that payment service. And there we have the pay method, and there we have some business logic or some print we are doing. So now different implementation can implement this contract. That is like this card payment, or suppose another class also can implement that payment service, right? So this is extremely useful for loose coupling. So uh, this interface when you will explain in that time also you can tell that in Spring Boot we will frequently see this interface based service repository abstractions. Okay, then also interviewer will be impressed. Next is the core Java. We will start, that is like first we will start with the constructor. What is constructor? Okay, so basically constructor is basically used to initialize an object. Okay, and has the same name as the class and has no return type. So it has the same name as the class and does not have any return type. So here one example, that class employee, it has the private string name, and then we have this uh, parameterized constructor. When there is the parameters in the constructor, it will be called as the parameterized constructor, and if it will be not there, that you can tell as the default constructor. Okay, so employee constructor, you can see the same name. Okay, and we can access the thing with the help of this dot name equals to name. Okay, so here employee equals to new employee, you can print any name. Okay, so when we write that one, so the constructor is basically invoked, and constructors can be overloaded. So they cannot be overridden because constructors are not inherited, right? Always remember that concept, that constructor can be overloaded. Okay, but they cannot be overridden. Why? Because constructors are not inherited. Okay, now this versus super. So this is one of the important concepts. So this refers to the current object and super refers to the parent class. So for example, like class child extends the parent string name, and child is a constructor, and there we are passing this string name super and this dot name equals to name. So these will be your current object, and this super will be the parent constructor. So this concept also you can tell as the constructor chaining. You can learn about it, or I will also discuss that concept, the constructor chaining. Okay, so this is the current class or current object here, and super is the parent class. Now what is static? So static means the member belongs to the class rather than an individual object. So suppose here we have the class counter, static int count equals to 0, then counter constructor count plus plus. Then we have done two times of like created that object. Okay, so system out.println counter.count. Okay, we will get as 2. First time it will be 1. That counter method will be called from here, and again this one. Okay, so that static means the member belongs to the class rather than individual object. Okay, so that's why static members are often used for class level state or some utility methods. Now, can static access non-static directly? Like you can think it like can a static method directly access a non-static variable like that way? So no, a static method belongs to the class, what I have told, but a non-static variable belongs to an object. Therefore, the static method does not automatically know which object you mean. So you need an object reference for that to access that. So suppose class test is there, int x equals to 10, and static void show method is there. So if you will do like system out.println and here x, okay, then you will get as error. Why? That is your static method. So from the static method, you cannot directly access the non-static variable. What you have to create, what you have to do, you need an object reference. So that's why from that class we have created an object test t equals to new test, and then if we will like print or return like t dot x, then from that it will able to fetch. Now what is final? So final changes behavior depending on where it is applied. Like for final, variable like cannot be reassigned. If final method, that then it cannot be overridden, and if final class, then it cannot be inherited. So suppose here we have made final int x equals to 10. If we will do x equals to 20, we cannot assign another value to x. Next, like we have the final class a. Okay, now if we want to do like class b extends this a, we will get the error, it cannot be extended. Okay, now final versus finally versus finalize. So these three are commonly confused. So final is a keyword, finally is an exception handling block, and finalize was a legacy mechanism associated with like garbage collection, and it's like deprecated currently. Okay, so it's deprecated for removal. So in modern Java application, don't use finalize for resource clear up. So prefer try with resource. Okay, for any cleanup operations or like that. So the interviewer also can ask you about the try with resource and all. If you know, you can comment below what is try with resource. Okay. So next question is, what is an immutable class? So an immutable object cannot change after it is created. So a typical immutable class has private fields, final fields, initialization through constructor, and there is like no setters, and defensive copies where necessary. So string is the most famous example as immutability. Okay, so immutability is very useful for thread safety and predictable behavior. Okay, so suppose this is final class employee, private final string name. We have made the constructor string name, this dot name equals to name, and public string get name, return name. Okay, so in that way we can implement, right? So now why is string immutable? As you are giving the example that as a immutable class, we can use the string. So next question will be like, why is string immutable? So suppose string s equals to Java. Now we are doing s.concat some space then world. So the original string does not change. Like whatever this string is, it will not be changed. So a new string is created. If we will actually print this system out dot print ln and s, we will get Java, not the Java space world. So when we'll do that, this s.concat, then basically a new string will be created. And string immutability basically provides several benefits. First one, you can tell security. So string pool optimization purpose. Then you can tell thread safety, stable hash codes. So this is why string is safe to use as a hashmap key. Like that interviewer also can ask, like suppose you were using some hashmap. So for a key, what you will choose, like any integer or any string or any other primitive type. So you can tell that we can use a string like as a hashmap key, right? Now the next question is like string versus string builder versus string buffer. So string is immutable, string builder is mutable but first, and string buffer is mutable plus synchronized, and that's why it's slow. So if I am doing many modifications in a normal single threaded application, I'll generally prefer string builder, like string builder SB equals to new string builder Java, then sb.append interview. And if we will print like system.out uh, println, we will get like Java interview. Okay, as string builder is mutable. So we don't create a new string object for every append in the same way repeated string concatenation would. Okay, but when there is like multi-threading platform or like that, then we should use the string buffer or for synchronized purpose. Okay, now double equals versus equals method. So for objects, double equals basically compares the references, and equals method basically compares logical equality when the class implements it like appropriately. So suppose string A equals to new string Java and string B equals to new string Java. Now system.out.println, you are checking A equals to B or not. So when you have created this string A equals to new string, then new object has been created. So like one reference. Then when you are doing string B equals to new string Java, then another reference will be created. So as this double equals will check the references. So both references are not same. So you will get the false. But through the equals method, we actually check the content. So both consists of Java, which is same. So that's why when we will apply that equals method, we will get the true. Okay. So after that, the equals method and hashcode method contract. So this is extremely important for HashMap and HashSet. So the contract says like if two objects are equal according to equals, they must have the same hash code. But the reverse is not necessarily true. So two objects can have the same hash code and still not be equal. So that's why whenever we override equals, we should normally override hash code too. So if you will just think the example, suppose when we are just calculate the hash keys, and on top of that, when we are actually we are implementing the hashing on some to generate the keys. Okay, so suppose we are doing through the modulo operator. Okay, so suppose one is 1 and another is 11. If we will do the modulo by 10, then 1 modulo 10 equals to 1 and 11 modulo 10 equals to also 1. So what, like, we are getting the same hashcode value as 1. But if you will check the content, that 1 and 11 through the equals method, though those are not same. But so that's why I have told, like, hashcode can be same, but it's not necessary that like through the equals also it will be same, like we may get the false. But if you just think about two values are like 21 and 21, so through the equals you will get the result as true. And if you will apply the hashing like modulo through the modulo operator, so 21 modulo 10 equals to 1, and 21 modulo 10 is also equals to 1. So for those two, the hash code are also same. So just think in that way. So when through the equals method we are getting the result as true, we will always get the if we will apply the hash code on top of that, like for those two values, we will always get the same result. Okay. So what if equals is overridden but hash code is not? So if equals is overridden and hash code is not, like here I have told, like, right, when we do the equals like when we will override the equals, we should normally override the hash code. So that's why the next question will be like, what happens if equals is overridden but we will forget to override the hash code method? So then hash code collections can behave incorrectly. So imagine two employee objects are logically equal. Okay, so suppose those two employee objects are logically equal, but because they generate the different hash codes, the hash map may place them in different buckets. So here you can see, suppose object, then we are implementing hash code, then bucket, and then we are checking the equals. So through the object, like when we will do the hash codes, suppose we have what I have told, like suppose two objects are like 21 and 21, we are doing some hashing and we are getting the result as 1 and 1. If we will not override, then what will be happen? That, like, when they generate different they will generate different hash codes, and HashMap may place them in different buckets. So therefore, HashMap may fail to recognize them as the same logical key. Okay. So this is why we like the equals or hash code contract is so much important. Okay. So if you will, again I'm telling, if you will not override the hash code, then they will generate different hash codes. Okay. And for that reason, when they will generate a different hash codes, then hashmap may place them in different buckets. Okay, and that's why hashmap may fail to recognize them as the same logical key. Okay, now the next question is like, what is the wrapper class? So wrapper classes actually allow the primitive values to be represented as objects. So when, suppose example, int x equals to 10, then integer y equals to x, that is basically auto boxing. So so for int it is like integer, for small long then it will be capital L long, double double. Okay, for char it is character. Okay, so in that way this becomes particularly important when working with Java generics and collections. Why? Because collections store objects, not primitive types. So that's why always remember, like whenever you will play with collections, you will work with generics. So in that point of time, don't forget to do the auto boxing. You will always need to use the wrapper classes, as collection and like generics, they all store the objects, not the primitive types. Remember this thing always. Next is autoboxing and unboxing. So autoboxing means converting the primitive to the wrapper automatically. Like integer a equals to 10, that's the boxing. And then int b equals to a, that is the unboxing. So autoboxing converts the primitive to wrapper, unboxing converts the wrapper to primitive. Okay. So basically Java extracts the primitive value from the integer, and Java basically handles that automatically. Now, what is an exception? So exception is basically, so an exception is an event that basically disrupts the normal execution of a program. Like for an example, int result equals to 10 divided by 0. So this causes arithmetic exception. So we can handle it using try catch. So inside the try block, we can put this int x equals to 10 by 0 and we can catch with the arithmetic exception. Okay. And we can return like cannot divide by 0, like that. Right. So that's one case. So after that, like we can tell like exception handling allows us to recover or respond appropriately instead of allowing unexpected failures to propagate uncontrolled. Okay. So next one is like checked versus unchecked exceptions. So checked exceptions are checked by the compiler. Example like IO exception, and unchecked exceptions generally extend runtime exceptions like null pointer exception, illegal argument exception, arithmetic exceptions, what we have done here. Okay, so a checked exception generally needs to be caught or declared, but unchecked exceptions don't have that compiler requirement. Okay, so that's why checked exception is called as the compile time uh, exceptions, and unchecked exceptions is called as the runtime exception. And checked exception should be handled, so compile time handling requirement is there. Okay, now the next concept is throw versus throws. So throw is used to actually throw an exception, like we can throw new illegal argument exceptions. Okay, so that is one. And throws is used in the method declaration, like void read throws IO exception, like that. But here, like if age equals to less than 18, we can throw new illegal argument exception as underage. Okay, so throw basically we use to actually throw an exception, and throws is used to like for in the method declarations. Okay, so you can take it like throw is an action and throws is the declaration. Now try, catch, and finally. So try contains the code that may fail, and catch basically handles the exception. And finally is generally used for cleanup purpose. Okay. However, for resources such as like files or database connections, so for that modern Java recommends try with resource. So in that case, we don't use finally, we use the try with resource. But as a nutshell, you can just remember, finally we basically use for cleanup purpose. Okay. Next, it is what is try with resources. So try with resources automatically closes the resources that implement auto closable. Okay, so it automatically close auto closable resources. Okay, so here you can see try buffer reader br equals to files dot new buffer reader. Then you can give the path, and then here we are reading the line. So once the try block completes, the reader is automatically closed. So this makes uh, basically code safer and avoids the resource leaks. So this is especially important in backend applications, which basically deals with files, streams, or database resources. Now, what is Java collections. We came into the part of collections now. So what is Java collection framework? So the Java collection frameworks basically provides the standard interfaces and implementations for storing group of objects. Okay, so it basically provides the standard interfaces and implementations of like for storing and processing the group of objects. So some important interfaces include like list, set, queue. Okay, and separately map is not part of directly collections. Okay, so common implementation include array list, linked list, hashset, linked hashset, tree set, hashmap, linked hashmap. When we use map, so then hashmap, linked hashmap, tree map, concurrent hashmap is also there. Okay, so the interviewer may next ask like when would you choose each other. Okay, like when you will use the array list, when you will use the linked hash map, like that. So that's where understanding the differences becomes important, like where you will use the linked list, where you will use the array list, where you use the hash map, when you will use the concurrent hash map. Okay, so first of all, array list versus linked list. So array list is backed by dynamic array, so that's why indexed access is generally you can say big O of one time complexity. When we use the list dot get, okay, so in that cases, like suppose list dot get 100. Okay, so linked list is based on the linked nodes. So like indexed access requires traversal. Suppose n number of elements, then for n number of elements it requires the traverse, so its time complexity can be big O of n, but for array list it is big O of 1. So therefore don't automatically choose linked list whenever someone says like frequent insertion is required. Okay, in that case you need to use the array list, but in real application like array list is often uh, better default because of memory locality and efficient iteration. Okay, so if for those cases you need to use the array list. Okay, okay. So now the hashmap versus hashset. So hashmap stores the key value pairs. So you can see the implementation, like you can in that way map string integer, you can see this key I have told if you will use the string it will be the best practice. So key is string, the value is integer, new hash map, we are putting the java comma 10 set, new hash set, this set dot add java. So closely see, for set we are using set dot add, but for map we use the put. Okay, so hashmap basically stores the key value pairs and hashset basically stores unique values. So internally hashset uses a hashmap like mechanism to track uniqueness. So always remember map is the key value pair, set is unique. Set we use for unique values. Now how does hashmap work internally? This is one of the most important question. So when we do this map dot put like java comma 100, so hashmap first obtains a hash from the key. So that hash is basically used to determine the bucket. The entry is stored in the in that bucket itself. Okay, so during get, like if you will do map dot get Java. So HashMap basically calculates the hash again and identifies the bucket and then checks the entries inside the bucket. But if collision occur, like multiple, suppose multiple keys, okay, like you have done the hashing and you got the same key, okay. So, at that point of time, collision basically occurs. So it means like multiple entries can occupy the same bucket. So in modern Java, sufficiently populated collision buckets can be transformed into red-black trees. But like there is a limitations. Like if there are maximum 8 same keys, those are basically stored in a linked list manner. But when the 8 cross, like the number of nodes crossed 8, then internally it will be converted into red black tree under certain conditions. And the average lookup complexity is at that point of time is big of 1. Okay, so that assumes like good has distribution, you can say. Okay, now can HashMap have null keys? Yes, HashMap allows one null key and multiple null values. Okay, but remember, like concurrent HashMap does not allow null keys or null values. Now HashMap versus hash table. So like HashMap is the modern general purpose map. It is not synchronized and allows null keys and values. But hash table is older legacy class. Okay, hash map is the modern general purpose map, but hash table is the legacy synchronized. Okay, legacy synchronized class. Okay, so it is synchronized and does not allow null keys or values. So in modern concurrent applications, if you need concurrent access, then you need to prefer concurrent hash map rather than hash table. Okay, next is like HashMap versus concurrent HashMap. So like HashMap is not thread safe. Concurrent HashMap is designed for concurrent access. So suppose multiple threads are updating a shared map. So using HashMap without proper synchronization can cause concurrency issues. So for that cases, you need to use the concurrent HashMap because it provides thread safe operations. And there is much more scalability if you will use concurrent HashMap because their entire map you need not to synchronized. Okay, so concurrent hashmap does not allow null keys or values. Always remember that, right? Now, linked hashmap. So linked hashmap basically provides predictable iteration order. So by default, it maintains some insertion order. Okay, like if you use the hashmap normally, or so they basically don't follow any order. But linked hashmap follow the order. Like whenever you will put map dot put 1 comma a map dot put 2, if you will print that you can get 1a 2b like that. So iteration will normally produce 1 followed by 2. So it can also maintain access order. So that makes linked hashmap useful for certain LRU cache implementations. So in some interviews, the interview can ask you to implement the LRU cache. You need to use the linked hashmap at that point of time. Now, what is tree map? So tree map basically maintains keys in sorted order. So internally it uses a red black tree. Therefore, a typical operation such as get, put, and remove are order of log n. Okay, so if you will do that, like tree map, here we are putting this 30C, 10A, 20B. By default, if you will print that map, then you will get 10, 20, 30 in sorted order. Now comparable versus comparator. So comparable basically defines the natural ordering of a class. For example, employee may naturally be sorted by ID, and comparator basically provides an external uh, sorting strategy. Okay, so the important advantage of comparator is that we can have multiple sorting strategies like sort by salary, sort by name, sort by joining date. Okay, all without modifying the employee class. Now we will discuss with some Java 8 plus features. So what is Stream API? So Stream API basically allows us to process the data in a declarative way. So imagine we have some list of numbers. Okay, suppose a list of 1 2 3 4 5 6. Okay, and we want suppose even numbers multiplied by 2. What can I do? So we can like use first collections, then we do like we will stream that collections, then we can filter out like in we filter out like in modulo 2 equals to 0, we will pick those things, we will filter out those things. After that we will map to like in multiplied by 2. Okay, and then we will convert this to list. Okay, so you can see the process here, and this is the steps. Okay, so the flow is like that: collection, then stream, then filter, then map, then result into list. Okay, so streams are especially useful for readable data transformation pipelines. Now, intermediate versus terminal operations. So stream operations are divided into two important categories: intermediate operations, which is like filter, map, sorted, distinct. Okay, so here you can see, suppose numbers dot stream, then we are just filtering out which numbers are greater than 10. So this filter, map, those things are intermediate. If you use sorted and all, those also intermediate. So these basically return another stream and are lazy. And terminal operations include like this: to list, collect, count, reduce, for each. So a terminal operation triggers the actual pipeline processing. Now, what is optional? So optional is used to represent a value that may or may not exist. So instead of immediately returning null, we can return like optional string. Okay, return type is, you can see, optional string. So optional string name equals to optional dot of nullable get name, then string result equals to name dot or else unknown. So this makes like absence explicit. So but don't use optional everywhere. So it's primarily useful for APIs such as return values where absence is a valid possibility. Okay, what is a functional interface? So functional interface has exactly one abstract method. For example, here we have annotated with functional interface, interface calculator, calculate method is there, then calculator add is there. Okay, so now we can use the a lambda, like here, yeah, I will show you anyway, but we can use a lambda, like here, suppose this calculator add equals to a comma b, a plus b. Okay, so common built-in functional interfaces include like prediction, like predicate, function, consumer, supplier. Okay, so those are the common functional interfaces. Okay, so through the predicate, actually, we like whenever some ternary, like so in that case, like we can return in Boolean format, like true or false. For that, actually, we use the predicate. Now, what is the lambda expression? So a lambda expression provides a concise way to represent the behavior. So instead of creating an anonymous class, we can write in that way. Suppose runnable task equals to, in that way, system out.println running, then task.run. Okay, so in the normal way, what we do, like runnable task equals to new runnable, then there maybe we have some method like run method, and there we print something like that, right? So instead of that, with the help of run like lambda expression, we can directly define in that way: runnable task, then uh, one this function, then lambda function, lambda expression, and then we can directly print this running, and we can use this task.run. Okay, so lambda expression became a major feature in this Java 8, and are heavily used with streams and functional interfaces. Now, what I was telling about this functional interfaces, that types like predicate, function, consumer, supplier. So here you can see. So there mainly four interfaces are extremely important for Java 8 interviews. So predicate, it basically takes the input and returns the boolean. Okay, so like predicate integer p equals to n lambda n greater than 10. Then function. So function basically takes the input and produces the output. Then consumer, it basically takes the input but returns nothing. It only consumes. Then supplier, it basically takes no input and supplies a value, like random value generation. For that time, we actually use that. So for easy way to remember, you can think like predicate is for condition, function is for transformation, consumer basically consume, and supplier basically provide something. Now, what is garbage collection? So Java automatically manages the memory through garbage collections. Suppose employee E equals to new employee. Okay. So later E equals to null, like object may now be eligible for garbage collections. So if there are no other reachable references to that object, so it becomes eligible for garbage collections. So the JVM's garbage collection, or that can eventually reclaim its memory. There is like garbage collector that basically reclaims the memory. So you can see the object created, reference removed, uh, object unreachable, eligible for garbage collections, and memory reclaimed. So we cannot guarantee exactly when garbage collection will be happened. So system.gc is only request or hint, not confirmation. Okay. Now stack versus heap. So this is another classic interview question. So stack memory is associated with individual threads. It contains method frames, local variables, execution informations, and heap is basically the shared across threads and uh, contents like objects and arrays, right? So employee is equals to new employee. So the reference E here, E is the reference, which is basically associated with the current stack frame. Okay. So the employee object itself is allocated on the heap. So remember, stack is for like method execution and local data, and heap basically for objects and arrays. Now, what is thread? So a thread is an independent unit of execution inside a process. So a Java application can have multiple threads working concurrently. For example, like thread T equals to new thread. Then here we are printing like system out.println running, and we T dot start. So when we call the start method, so at that point of time, so the JVM basically creates new execution path, and it invokes the threads run logic. Okay, so threads are fundamental to concurrent backend applications. So you should know about threads, process. So in process, actually multiple threads can work togetherly. Okay, but thread is a single unit. Then start versus run. So this is a very common trick question. So consider like thread t equals to new thread and system out.println thread dot current thread dot get name. Then t dot start, it is the new thread, and t dot run, the current thread. So if we call this t dot start, so actually a new thread is started. But if we call the t dot run, so we are simply calling the method normally on the current thread. So we are normally calling the method on the current thread itself. So always remember, start is for the new thread and run is for the normal method invocation. Okay. Now next is like, what is the synchronization? So suppose two threads modify the same variable simultaneously. Okay. So we can get a race condition. So synchronization basically allows us to protect a critical section. Like here we have uh, this method like public synchronized void. This is the synchronized method. Okay. So this is the synchronized method. So here the synchronized method uses the object's monitor. So only one thread can enter the synchronized section for that monitor at a time. But synchronization should be used carefully because excessive locking can reduce the performance and can contribute to deadlocks as well. And we can achieve the synchronization in many ways. Maybe I will cover that in separate video itself. Okay, the total synchronizations process and all. Then what is volatile? So volatile is primarily about the visibility between threads. So suppose thread A changes a volatile variable, so other threads are guaranteed to observe the updated value. Actually, it basically updates directly to the main memory. That's why other threads can see the change. Okay, so other threads are guaranteed to observe the updated value according to the Java memory model. So if we will define it like that, like private volatile boolean running equals to true, so it's good for visibility. While we're running, it will work. Okay, so suppose for an example, if you will do count plus plus, so that is not a single atomic operation. So it is essentially read, modify, and write. So for atomic counters, okay, we can use the atomic integer. So that also you can learn about the atomic integer, atomic variable. Okay, as like through the volatile, we cannot achieve the atomicity, right? So now what is deadlock? So deadlock occurs when two or more threads wait indefinitely for resources held by one another. So imagine thread A holds lock 1 and waits for lock 2. Now thread B holds lock 2 and waits for lock 1. So neither can continue. That's basically deadlock. So one way to prevent this is to always acquire locks in a consistent order. So another option is like suitable cases is like try lock with a timeout. Like for a particular time, that lock will work. After that, the lock will be freed. Okay. So in production systems, like deadlocks can cause serious availability problems. The next concept is executor service. Okay. So finally, let's discuss about the executor service. So instead of manually creating a new thread for every task, we can use thread pool. Okay, so here you can see the executor service executor equals to executors dot new fixed thread pool, right? So here we create a pool of 5 worker threads, and tasks are basically submitted to the executor. So the executor basically manages which worker executes which task, and the flow is like task to executor service, then thread pool, and then worker thread. So this basically provides better thread management, reuse the controlled concurrency, and in production applications, frameworks often manage executor life cycles for us. But like understanding the underlying concept is extremely important. Okay, so these were the like 60 Java basic interview questions that you should be comfortable with before appearing for a Java developer interview. But I want to notice something like these 60 questions are not isolated topics. They form a connected chain basically. So we started with, if you remember, like Java, JVM, white code, then oops, encapsulation, inheritance, polymorphism, abstraction, then the core Java, then string concept, equals has code, then exceptions, and then finally like this collections, has map, concurrent has map, linked has map, then Java 8. There we have discussed about Lambda, functional interface, stream API, right? And finally, this memory, threads, synchronization, volatile, deadlock, and we have finished with executor service. Okay, so if you understand these connections rather than memorizing individual answers, so your Java interview preparation becomes much stronger. And one more important suggestion is like don't stop at these 60 questions. In an actual interview, the interviewer will usually ask follow-up questions. For example, if I ask you, how does HashMap work? The next question could be like, what happens during collision? What is the role of the hash code? What happens when the bucket becomes highly populated? Why should equals and hash code be consistent? Similarly, if I ask about volatile, the next question could be like, does volatile make count plus plus atomic? That I have discussed already. So, and if I ask about stream API, what is lazy evaluation? Then suppose difference between map and flat map. What is parallel streaming? That's how actually real interviews usually progress. So make sure you understand the why, not just the definitions. So if you found this Java interview preparation useful, consider subscribing to the channel. And in the next session, we can go deeper into advanced Java, Java collections, multi-threading, Java 8 streams, Spring Boot, and microservices interview questions. In that way, I can continue actually. So thank you for watching. See you in the next one. Bye.